Today, we will be discussing geometric sequences given a certain situation. So if we look at this, we have a phone tree is when one person calls a certain number of people, then those people each call the same number of people, and so on. In the fifth round of calls, 243 people were called. Write an explicit definition to find the number of people called in each round. So first, let's talk about the explicit definition of a sequence. We take a sub n, and it's equal to the first term times the common ratio raised to the n minus 1 power. Looking at this picture on the right, we see that the first term is equal to 3. So a sub 1 is equal to 3. And then they tell us that the fifth term is equal to 243 because the fifth round of phone calls gives us 243. Now we just need to find the common ratio, which we are going to use the explicit formula for. So we have the fifth term, so a sub 5 is equal to the first term times the common ratio raised to n minus 1, but we know what n is, because in the explicit formula, the nth term is equal to the n in the exponent. So those two n's are equal. So if we have the fifth term, that means r is raised to the 5 minus 1 power. So sub in, we get 243 is equal to 3 times r raised to the 4th power. Now we just solve for r. We solve for r by dividing by 3 on both sides. We get 81 is equal to r to the 4th power. To get rid of the 4th power, we're going to take the 4th root of both sides. So that leaves us with r is equal to 3. So our explicit formula here is a sub n is equal to 3 times 3 raised to the n minus 1 power. Knowing that, that's going to help us get part B. It asks us how many people were called in the 8th round of the phone tree. So we're looking for the 8th term. So a sub 8 is equal to 3 times 3 raised to the 8th power minus 1. So that's really 3 times 3 to the 7th. Once we simplify that, we get 6,561 people. We're talking about people for this one, so it's 6,561 people. On the next page, we have sequences versus series. So a sequence is what we have been doing. It is a list of numbers. The numbers are separated by commas, and then we have the explicit formula. A series is a sum of numbers. The numbers are separated by addition signs, and we have summation notation. So we kind of have a sideways looking m, but it's called sigma. And then we have n is equal to 1, and then it goes all the way up to the kth term. So that's the number signifying the last term in this series. Then the first term, the common ratio is there again. So we're going to be looking at the summation notation in the next example. So write the expanded form. So this is example 4. Write the expanded form of the series. You have the summation notation here. from n is equal to 1 to the 7th term. And then we have our first term, which is a sub 1, and then our common ratio, which is r. So expanded form, we're going to write that down here. The first term is a sub 1. Remember, we're doing a series, so we're going to have addition symbols in between. And then the common ratio is 2/3. So to get the next term, we take the first term times the common ratio. So that's going to be 3 plus 2. And then plus, and then you keep multiplying by 2/3. So 2 times 2/3, that is 4/3. Then we have 4/3 times 2/3, which is 8/3. And we have to go all the way up to the 7th term. So right now we have 1, 2, 3, 4. We have to keep going. And this 8/3 should be 8/9, because we're multiplying by 2/3. Then we get 16/27 plus 32/81 plus 64/43. So that's the expanded form of the series. You have to keep going until you get to the 7th term. And we have 1 term, 2, 3, 4, 5, 6, 7. And you can see the common ratio. As we go up in the series, you're constantly multiplying by 2/3. And now we need to find the sum. So to find the sum, we actually have a summation notation for, or a formula for. You have S sub n is equal to a sub 1, so the first term, times 1 minus r to the nth power, all over 1 minus r. And I'm going to erase all of this to get this out of our way, because now we are going to find the sum. So looking at this, remember these two n's are going to be the same. And then we have r, which is the common ratio. So you have s, the nth, or the last term. This 7 is going to be equal to these two n's. So you have s sub 7 is equal to the first term, which is 3 times 1 minus the common ratio is 2/3 raised to the 7th power, all over 1 minus the common ratio. Once you enter that into your calculator, you should get 8.47. And that is the sum of that series that we just wrote out. We have one last example. We're going to write the series using sigma notation. So right now, this is an expanded form. We want to write it using sigma notation, which we have to recall is the summation of n equals 1 to k of a sub 1 times r to the k minus 1. So our first term, that's -2. That's going to replace a sub 1. We need to know what the common ratio is. And just like with the sequence, we can take the second term and divide it by the first term. So if we do that, we get our ratio to equal 1/3. So that's going to equal R. So now we have the sum of n equals 1. We don't know what k is yet. We don't know what that last term is, but we do know the first part is -2, 1/3 raised to k minus 1. We just need to know what this number is up here. So we're going to take the last term in this series and use what we have figured out to figure out what k is. All right, so again, I'm going to erase this to give us more space. Then we know -2 times the common ratio k minus 1 is equal to -2 over 243. So now all we have to do is solve for k. So we're going to solve for k. We can get rid of this -2 by multiplying by -1/2. Doing that, we can cancel out these 2's. A negative times a negative is positive. So we get 1/3 raised to the power of k minus 1 is equal to 1 over 243. Now to figure out what k is, we can either graph this, or since we're trying to solve for an exponent, switch it to log form. We have log base of 1/3. Answer is 1 over 243 is equal to our k minus 1. So simplifying that, we get 5 is equal to k minus 1. Solving for k, k is equal to 6. So now we have our summation notation. Or at least we have this top number. Now the only thing we have left to do for this part B is to find the sum. We have written this expanded form into sigma notation. Now we just need to know the sum. And the sum is going to be the sum of all those 6 terms in the series. So it's going to be S sub 6 is equal to the first term times 1 minus the common ratio raised to the 6th over 1 minus the common ratio. And simplifying that, we get a sum of -2.996. And that was our last example.